All right, let's get started. Hey, everybody, this is Nirmata. Um, today we want to, thank you for joining the meetup. Today we're going to talk about uh, a couple of different topics related to containers and Kubernetes. The first one is going to be around managing Kubernetes cloud costs. And Ben from Octane is going to talk about it, and he'll be going first, and then after that, I will cover the topic around automating Vault and secrets management for Kubernetes clusters. So without any further delay, I'm going to stop sharing, and Ben, you can take over and start with your topic.
All right, sounds good. All right. Hello, everybody. My name is Ben Hundley, and I'm an engineer at Octane. And today I'm going to be talking about Kubernetes cost management. So just kind of a picture of today's world. The cloud's pay-as-you-go model has made resources more readily available and easier to consume. Monthly bills are how we learn about how much we've spent. Multi-tenancy and microservice architectures are growing rapidly with containerization, and dynamic provisioning and auto-scaling are essential to all our deployments. The problems with that is that cloud bills don't translate to Kubernetes or business terms. The breakdowns, while very verbose, are rarely useful or easy to understand. There's no Kubernetes-based line items, stuff like cluster, pod, and namespace. And because of that, it's hard to attribute costs to microservices or tenants running on the hardware. And oftentimes, this isn't real-time data. And so because of all that, it's easy to pay for far more than you're using. And your bill won't reveal the wastage like idle resources. And there's really limited controls available to you to curb spending. So you think this is fine. You really aren't exactly sure. So cost visibility is the answer to your problems. Because if you look at, this is just a cloud bill example from Amazon, it shows you the type of resource and the amount of hours you use, but it doesn't map back to your business and it doesn't give you any meaning here. So you're not really sure what's in there. If you were to have a go at this yourself, if you were to have the ideal cloud bill, do it yourself, the two main pieces would be metering and attribution. So cost metering is something that could be built on top of your existing observability stack or your monitoring stack. And your monitoring stack is collecting infrastructure measurements. Prometheus is a popular tool for observability in Kubernetes. And stuff like CPU and memory and disk usage, all of that can be pulled from the native metric server. And stuff like network metrics, they're a little more challenging. And a shout out to Kubernetes, it's actually developed by Nirmata, is something that we've used to get information on network usage. But it is a lot of data. And so you have to do a little bit of boiling down to get to some summary metrics there. But after you have all of those measurements, the final step is just deriving cost from those time series and from the cloud price list, which is admittedly a problem in and of itself because every cloud has different ways of reporting prices and different APIs and such. And so that alone will get us further than the cloud bill, right? That gets us to Kubernetes level line items, but it still doesn't show the whole story. It doesn't tell you specifically what applications or what teams might be contributing to the cost. And so to do that, you really need to track metadata over time, just like the metrics, stuff like namespace, name, labels, and annotations. And something we've used for that, this is another Prometheus exporter like Kubernetes called Kube State Metrics. And that will just export all of those metadata metric points over time. So once you have that, cost aggregations can be sliced however you want. Time window, customer team, project, region, etc. So just to show you a little sample of what this looks like with Octane. So here we have aggregated metrics for all of our costs on AWS. You can see we're only running on Amazon. That's the one provider, but we could, if we had this cluster cross-provider, or we had clusters cross-provider, we would see all of that here. And it gives us a nice breakdown of machine, compute, storage, and network. You can even open up network and drill down even further to whether it's internet, interzone, or intrazone, all of which are built differently on the cloud. And so this is the really cool part. You can see here we have the aggregation, the aggregated summary of the single cluster we're tracking, but we can go a step further. We can break down by namespace. We can go a step further than that, and we can look at some of the application labels. We can see all the different services we have running here. This pie chart over here shows you a nice little representation of the share. And we can even slice down into a smaller time window. So this is what we kind of envision as a more useful cloud bill compared to the dry resuscitation of your infrastructure bill. So getting back to the presentation here. So getting into cost optimization, once you have the visibility, some strategies to keep you lean, to make sure that you're not a little chihuahua driving a huge truck, to make sure you're not oversized for what the value you're delivering is. So one approach is you can think of it like defragmentation or consolidation. So auto scaling is used in a lot of Kubernetes setups. A new pod comes in, it doesn't have room on any of the existing servers. The autoscaler adds another server. And over time, pods reshuffle, they're deleted, and these holes start to form in your nodes that may not ever be filled. And you have a fragmented cluster that's under optimized. And so a part of your autoscaling implementation or a completely separate service could be set up to look for situations like this. And you can, the draconian way would be just delete the node and let Kubernetes move the pod over. But you could take, more delicate care if you have stateful workloads, mission critical workloads like databases, and you can set stuff like disruption budgets to make sure that if you do implement something like this, your pods can move around gracefully. Another thing, batch jobs on transient VMs. So this can really be something to bring your compute bill way down. If you're not familiar with spot instances, it's just a kind of a secondhand market to bid less than the market value for a server, and you're competing with other people. And so as long as you're bidding more than what the market's willing to pay, you can control that spot instance. But since there's competition for the bidding, your bid might fall lower than the market price, and then you're kicked off that instance. And so you have this kind of sea of rotating instances. For stateful workloads, mission critical things like databases, that obviously can't work. But for something more stateless, something like, for example, training a machine learning model, stuff you can do in batches, you can save a ton of money by running that on a spot instance base node set. And this I just linked here. If you want just a little bit more control and making sure things terminate gracefully, AWS has this termination handler for running situations like that. So saving on networking. Here, this is just a diagram I pulled from a cool little GitHub repo called Open Guides. And this just shows how networking costs are billed in AWS. You can see there's some complexity to it. And really there's not, it's hard to optimize for networking, but one specific case to keep an eye out for is interzone costs. So traffic in the same zone between servers, for the most part, you don't pay anything for. I think in Amazon, it's zero, completely free. But if you move traffic cross zone, it jumps up to 2 cents per gigabyte. And a lot of times with cross zone clusters, You set that up purposefully so you have failover if one zone were to die. But what can happen is if you're not paying attention, let's say you, for example, have two pods that are, two different microservices that communicate back and forth with each other constantly, and generate, gigabytes of data, every day. If one of those pods shuffles across zones, suddenly you go from spending $0 to 2 cents per gigabyte for every piece of information that goes across the zone. So that's one thing to keep an eye out for. This is definitely probably the lowest hanging fruit from my personal experience. In the cycle of development, you'll create a cluster, clean it up, new cluster, clean it up, new cluster, clean it up. Before you know it, you can wind up with a lot of orphaned resources. Load balancers could be included here as well, but disks are the thing that can really be a cache sink. So you can automate the cleanup of orphan volumes. You could use a serverless function, something like Lambda. And AWS actually has a good article on this if you wanted to Google that. You would have to enable CloudTrail to keep track of how long the volume's been detached. But outside of that, fairly easy to implement. So this one is a little more advanced, but again, comes from my personal experience. You could, for example, have a cluster comprised of servers that have local ephemeral disks. It's free real estate, as you can see. That's not always the case. And actually, EKS, GKE, a lot of these services, the instances are network attached storage only. There aren't local disks. But if you have the local disks and you aren't utilizing them, it's definitely something to take advantage of. But there are definitely caveats. Have to understand the trade-offs. If it is mission critical data, you're going to have to replicate it to make sure that if a node dies, you can recover it. Alternatively, since live replication is expensive, you're going to end up using more compute power. An alternative just to mitigate data loss would be setting up a snapshot and restore process. And so Valero is great for backups, and OpenEBS is a cool storage operator that if you're running on bare metal or if you're running in the cloud and have a lot of ephemeral disks that you're not making use of because of all the challenges, OpenEBS, definitely check that out because it can make your life a lot easier. So we've got visibility, we've got some basic optimizations in place, continuous governance, that's really the final stage. And as you can see, this is what your devs on AWS look like. How do you keep them in check? So internal compliance. Policy agents right now are something that I think are very, very cool. It's a way to enforce and automate expectations for how your team should label resources, for how they should organize their resources. And so you could, for example, enforce that team Y has to have label X. And of course, you have to have RBAC in place, role-based access control, to know that team Y is communicating with the server. But assuming you have all that, since it's a multi-tenant cluster, a policy agent is something that can make sure all of your resources conform to the business's expectations. Measurements are only useful if they're properly labeled and properly tracked. And building on that idea, so Kyverno, Nirmata develops Kyverno, very cool. And another alternative is Open Policy Agent. Both of these things, really, when you get down to brass tacks, they are handling admission webhooks for Kubernetes. And so in Kubernetes, there's two types of admission webhooks. You can validate, you can either accept or deny a resource based on what that resource looks like or who's submitting it. And there's mutating webhooks. You can modify resources. And so there's all sorts of stuff you could do here. But if we're incorporating cost aggregations into this policy data, we can do stuff like making sure a team can't create new resources if they're over budget. If they are over budget, we could make sure that the pods they create only go to lower quality nodes and such. So now that we've discussed that, I just wanted to show a little demo of how one of these policy integrations would work. So I have a cluster set up here, and we've actually installed what's called, I don't know if it's called Hipster Shop anymore. It might just be called Google Microservices Demo, but it was previously called Hipster Shop. It just has a bunch of microservices and a load generator. So it's generating a lot of network traffic, causing a lot of compute usage and storage. And we've got several of these set up in different namespaces. Excuse me. And so I can go in here and you can see those namespaces: LeBron James, Lionel Messi, Serena Williams. Zoom in on the time window here. And so let's say that LeBron James, I see that he has spiked up recently. He's normally about $68 a month, but he has recently spiked up to spending about $100 a month. So I could, for example, go into my teams page here, and I already have an aggregation set up, or a team set up, I'm sorry. And you can see what this looks like. When you go to create a team, you name it. And this goes back to cost attribution, right? This filter, this is how we, from Octane, say this team maps to these resources via this aggregation. So we can just, for this, say namespace, and we're looking at the LeBron James namespace. And if I click preview, it will pull up just the LeBron James items. I can, once I've done that, I can set this enable spend rate cap. So we had saw that LeBron James was spending around, I think it was like $70 a month. We could, for example, set a cap to 60. Go in here and click save. And then you see how this is actually red now. So we're over budget. And if I go over here, I have a command I was using, just spinning up a simple like Ubuntu pod in the LeBron James namespace and opening bash. So just trying to spin up an interactive terminal to use. So you can see here, it did not allow me to do that. It said error from server, denied by Octane spend cap, and you're currently violating budget constraint. So that's all good. Let me just show you though that this is normally working. So I go in here, let's enable this spend rate cap. Let's make it something more reasonable, set it to 1,000 and save. No longer red, we're in the clear. I should be able to go back over here now and rerun that. And I'm in. So that wraps up the Octane demo, and thank you guys very much for listening.
All right, thanks, Ben. Just for, I guess, everybody's information, can you let us know if somebody wants to try this out, what would they do, and how would they reach out to you?
Yeah, so just go to getoctane.io, and you can contact us from there, and you can even sign up, check it out, and we'll definitely be in contact.
All right, looks like Zoom is frozen for me. Let me log back in. All right. Can you hear me, Ben?
Yes, I can.
All right. So it looks like Zoom just gave up on me. I had to log in again. All right. So let's move on to the second part of the meetup. I'll cover the Vault automating Vault configuration, and I'll start with a few different slides, and then get into a short demo. So really, just in terms of quick background, I'm one of the founders at Nirmata. We've been in the Kubernetes cloud native space for 5+ years, and are active member of CNCF. We with open source projects like Kyverno, Kubernetes, and are working with customers, helping them adopt cloud native technologies and Kubernetes. And really, as Kubernetes has evolved, what we've seen is as enterprises adopt Kubernetes, they end up facing several challenges around day two operations. Right, it could be from ensuring that Kubernetes configurations are are secure and valid, uh, providing getting like visibility, ensuring governance, just like the demo that Ben showed a few minutes ago. And then as the developers adopt self-service, whether it's for Kubernetes clusters or virtual clusters, how to manage and mitigate cluster sprawl. So that is where the Nirmata comes in, and we provide a unified management plane that spans across public cloud, private cloud, or any other custom clusters that maybe have been deployed in an enterprise. And we provide various services, including self-service, governance, IAM management, and so on, across those clusters. So one of the things a few of the use cases that we address and we'll talk about today are around self-service clusters and central management of add-on services for those clusters. We do also support multi-cluster application rollouts, security, configuration security, and governance through Kyverno for workload policies, and then automating resource utilization and optimization. So today we'll focus on the first two as we look at how this can be done for HashiCorp Vault. So let's start. Let's talk about Vault and why secret management is needed in Kubernetes. So in Kubernetes, as you're deploying applications, in several cases, applications may contain or require sensitive data. Whether they're passwords, tokens, certificate, keys. Now, the best practice is to not store these in your Kubernetes manifest, as in not expose these in these credentials or certificates into the outside world, right? So you want to avoid things like hard coding these in your application, in your Kubernetes manifest, packaging them with code, like as you're building out things like Helm charts or other kind of packages. You don't want these to be included necessarily in there. You don't want them to be inserted through build tools, again, because ultimately they end up somewhere in the container or on the disk. And even if you set them as environment variables, again, they are visible to anybody who has access to that container. So there's definitely these best practices. These are these anti-patterns that you want to avoid, and there are best practices for managing secrets. And one of the components or one of the tools that lets you do that pretty elegantly is Vault. So Vault is a secrets management tool from HashiCorp. Essentially, it ensures that your secrets are stored in the vault, and they can be dynamically retrieved by any authenticated, authorized, application or container or pod, right? So what Vault does is it helps you automate secrets management, provides like a central place where all your secrets are, so it's easy to manage, these secret certificates as well as audit them. It also provides a level of encryption so that your credentials are not leaked as they're transferred from Vault to your application. And the nice thing is it's a tool that sits outside. It's an external tool, so it doesn't need to be tied to a specific cluster or specific infrastructure. So you can use it across all of your infrastructure, your multiple clusters, or if and potentially even across clouds. So when you start using Vault and when you want to use Vault for secrets management, there are a few things that need to be done. So secrets in this with Vault are dynamic. They're generated when the client requests them, and these credentials are per client. So clients need to identify themselves, and they need so that they can retrieve these secrets. That is done through a role that the client can expose, and then credentials are deleted as once the lease expires, so you don't have the credentials kind of lingering around and potentially getting misused. So in order to get to enable secrets management with Vault, um, you are you need to set up Kubernetes authentication method in Vault. Um, so in order to set up or configure secrets, you need to set up Kubernetes authentication method in Vault for each cluster. And then if you want to dynamically inject these secrets into your running pods, a Vault agent injector needs to set up in the cluster. And this setup needs to be done for every cluster that you want to enable Vault with. So in this case, here is a quick kind of a diagram of what this looks like. So as let's say you have developer or an admin provisioning a cluster. In this case, you say they're using Nirmata to provision the cluster. And when they provision this cluster, they can actually specify in Nirmata, you can specify that this cluster should be using Vault. And then once you do that, Nirmata can take care of actually provisioning the cluster, getting the token and the certificate from the cluster, and adding that to Vault. And so basically the authentication method for that cluster is added to Vault. And then Nirmata would also deploy the Vault agent injector. And once that is done, now any application that's deployed to the cluster can start using Vault to retrieve secrets. So we will use this. We'll do a short demo on this and show you how this works. And as we're doing that, if you have any questions, please please put it on the YouTube live chat feed, and we are monitoring it so that we can respond to any questions towards the end of the presentation. All right, so I'm going to switch to Nirmata that I have set up here. So just first, I'll walk through the quick setup. So I have Vault, which is something that is set up, which we are using. This Vault currently has one cluster, this GKE Vault 1, which is already set up, and we'll add another cluster as part of the demo. Now, there is also the Vault agent in the injector YAML, which is available on our GitHub page. And we also have it in the Nirmata catalog. So first thing, in order to kind of enable this integration in Nirmata, we need to set up Vault and give Nirmata the access to just add limited access to in Vault to add the authentication path, right? Nirmata should not be able to do anything else except provision that authentication, Kubernetes authentication path. So once that is done, now we are ready to use, ready to start configuring Vault as we provision clusters. So in Nirmata, we have a concept of what we call cluster types. And these cluster types are essentially, think of them as templates where you can specify how you want your cluster to be created. So for this demo, I'm going to use our Google or a GKE Google account to spin up a GKE cluster. And here in this cluster, we have some configuration for GKE. We specify the type of node pool we want. And then we're also specifying this cluster. We're going to install Kyverno on this cluster, as well as the Vault agent injector. And then also the Kubernetes, the authentication settings for Vault will be installed. So as part of this installation, we'll set up Vault so that it can be, this cluster that we provision can use Vault. And then we will also set up a role called Nginx demo, and we can use that role to deploy our, when we deploy our sample application. So to provision cluster, once the cluster type is created, it's pretty straightforward. You can just click on GKE cluster here. I'm just going to call it GKE Vault demo. Select my Vault cluster type. It's going to show me, if I can specify my node count, enable auto scaling if I want. But that's pretty much it. And once you do that, that cluster is now in the process of being provisioned. So while in GKE, this is pretty quick. This cluster takes about 3 to 5 minutes to actually be provisioned. What I'll do is I'll show you what we have in the catalog. So in the catalog, we have the Vault agent injector. So that's what gets actually added to the cluster once it is provisioned. And this Vault agent injector injects a sidecar into your application, which can fetch the secrets from Vault once the Vault is set up for that cluster. And then we also, in the catalog, we have our Nginx demo application. So this is the Nginx Vault demo application. And the main thing to do over here is any deployment or stateful set that requires the Vault injector to be added, or requires to retrieve secret, you need to add a couple of annotations. So first annotation is for the role. And in here, essentially, you're saying this deployment is going to use this role to fetch the secrets from Vault. And this other annotation just tells the Vault agent injector that a sidecar is needed on this cluster or for this deployment. So I think once those two are set up, it's that's it pretty much. Now, as you deploy your application or your into Kubernetes, all of the other configuration is done automatically. So let's go back to the cluster. So while this GKE Vault demo is coming up, I have another cluster here called GKE Vault 1. You can see the Vault agent injector is already added on this cluster. And this cluster, we looked at it earlier, has the authentication method that's already created. And it is, if you look at the configuration, it has a role called Nginx demo that's already created, right? So now what I'll do is in Nirmata, go and create my environment, which maps to a namespace. In a medium environment, I'll pick the GKE Vault 1 cluster because the other cluster is not ready yet. So for now, I'll just pick this one. And then I'll use Nginx as my namespace name and click on OK. And then now I'm ready to run my application. So I'll pick my Nginx application from the catalog. This is the one which requires Vault to be configured. And once I deploy, You can see in a few minutes the deployment should start. If I go to the pod, the interesting thing I'm going to see is there is a Vault agent init container that's added, as well as the sidecar that's added for this. And within a few seconds, the pod is up and running, and I can actually look at the pod and look at the sidecar and look at the logs, and the logs are now fetching the token from Vault, right? So now this is essentially, that's pretty much all you need to enable Vault with your application. Um, once you deploy, once you set up the Vault authentication path, as well as add the Vault agent injector, any application that has those annotations set can retrieve the secrets. So let's go back and look at our cluster. It's still in the process of being created. That may take a few more minutes, but that's really what this looks like. You pretty much, as part of the provisioning, we set up Vault, and we can configure the Vault authentication path and deploy the agent injector. And this is very important when you want to do Kubernetes self-service, because setting up, like we saw in the slide, setting up Vault requires a two-way kind of handshake between the cluster and Vault itself. And Nirmata automates that, and so that any cluster that gets provisioned and requires Vault, it's all of the handshake and all of the configuration is automatically done. So that's pretty much it for this demo. Let's see if there are any questions. So just in case you want to try this out, Nirmata is available as a cloud-based service. You can go to our website, www.nirmata.com, and sign up and try this out. Or if you want to reach out to us, through email or through our Twitter handle, please feel free to reach out, and we're happy to provide more details. Obviously, the video is being streamed live, and it'll be available on our YouTube channel. All right, so I think one question is around this comes up pretty often. Does Nirmata work with the Vault? I think HashiCorp recently announced the Vault Cloud, and does Nirmata work with that? And just kind of at this point, we haven't done any validation with that, but we're in the process of working with HashiCorp to do that validation and support that as well. All right, looks like there are no other questions. Ben, anything you want to add? Any final thoughts before we wrap up?
No, that'll be it for me. I appreciate you letting me come on this, and thanks everyone for listening.
All right, thank you everyone, and yes, reach out to us if you have any further questions. Happy to hear any feedback or any other thing you want to discuss. Thank you. All right.